Recall from the earlier videos that we have already found the modulus and argument of z and w. So very quickly, I'm just going to write it here. The argument of, given that z is equals to negative square root 3 plus I, alright, the modulus of z is just equals to 2, and the argument of z will be equals to 5 pi over 6. Okay, this is from the earlier video that we found just now. If you forgot, just go back and look at PQ part 1. Okay, PQ1, this is the w, the modulus w. For square root 2, the argument of w is equals to pi over 4. Okay, and from here, we are going to look at part 4. Okay, PQ1 part 4, we are required to find the evaluate z asterisk z conjugate over w. Okay, so first, leaving the answer as a polar form. So what we're going to do is we're going to, number 1, find the modulus of part 4. Number 2, find the argument. Okay, so we're going to find the modulus and argument. So remember that I told you during lecture that we need two friends, right? One must be the modulus, one must be the argument. Okay, so let's go and do this. And z asterisk, if we were to look at the modulus of z asterisk over w. Okay, so remember I said that the modulus of the quotient is the same as the quotient of the modulus. Okay, and what is the modulus of z conjugate? This is actually the same as the, remember we talked about this before, it's the same as the modulus of z itself. Okay, so remember if a quick proof that if z is equals to x plus iy, alright, mod of z is a square root of x squared plus y squared. Z asterisk, if it's equals to x minus iy, modulus of z asterisk will be the same as the, again, the square of the real part and the imaginary part, which is negative y square. And this is the same as x squared plus y squared, because negative y bracket square is the same as y squared. So you can see that these two, they are equal. Right, they're equal. So z asterisk modulus is the same as z modulus. Alright, so quickly, after I'm sure I'm going to erase it so it doesn't interfere with the working. Right, it's the same as equals to mod of w. And mod of z is equals to 2. Mod of w is equals to 4 square root 2. And with that, your answer just comes out to be square root 2 over 4. Okay. Okay, next up, what about the argument of z asterisk over w? The argument of z asterisk over w is the same as the argument of z asterisk minus the argument of w. Okay, remember, the argument of a quotient is the same as the differences between the two arguments. And argument of z asterisk, okay, again, is the same as the negative of the argument of z. Okay, I hope you know this. If you don't know this, go and look at my previous video. It's the minus the argument of w. Okay, so here, I hope you recall the tip that I use here is that the argument of z asterisk, okay, is equals to the negative of the argument of z. Okay, so I hope you are able to manipulate this. And very quickly, our answer is just equals to negative 5 pi over 6, which is a negative of argument of z, subtracting the argument of w, which is pi over 4, and the final answer comes out to be negative 13 pi over 12. Okay, and negative pi over 12, okay, we realize this is not actually within the, principal range, right? So we want the principal range to be between pi and negative pi. So negative 13 pi over 12, what do? We basically, if the answer is too small, we add 2 pi to it. If the answer is too big, we can minus 2 pi from it. So depending, it can be 2 pi, it can also be adding and subtracting multiples of 2 pi. In this case, negative 13 pi over 12 is not within the principal range. So what do we need to do? We need to add 2 pi to it. So if you add 2 pi to it, so over here if you plus 2 pi, right, if you plus 2 pi to it, right, your final answer will be 11 pi over 12. Okay, is it equal? Remember I told you during lecture that we do not put an equal sign, we put an equivalent sign. Okay, so take note that we have to maybe just put in yellow here. Remember, we have to put an equivalent sign. We have to put an equivalent sign, okay, not an equal sign. Okay, so I've said about this during lecture. Hope you actually can remember this, right? And this is the for PQ1 part 4. Okay, very quickly, now we need to express the answer in the polar form. Okay, so we have our modulus, we have our argument. Okay, we are ready to write it in the polar form. So z asterisk over w, this would be square root 2 over 4 r cos theta plus I sine theta. Okay, and this would be PQ 1